with that epsilon, we can change this entire way of understanding. So we know that there is a epsilon already present. We can enhance that. We can use this epsilon to find. So if I want to check simply, is it equals to 0.3? I will always get false value, right? This is false, but according to logic, should be true. Hey, if you would like to understand why 0.1 and 0.2 is not equal to 0.3, you can check out this short video. What we'll do, we will create a function. See this code I have added here. What it means that if x and y, so I will take x and y. I'm trying to check both value are equal or not. Okay. So if f(x) and equals to y, then I will say x is equals to y. And if it is not, then it will say not equal. So same, I will try to put that into. So this will always give me false, is not equals to false, right? But how we will do, we will add a epsilon property here. So I want to add inaccuracy by 1, some degree of inaccuracy here. So let's modify this code little bit to make it so see this code. So what I did is we added math property. So math ABS means absolute. So whatever you put inside this function, you will always get positive number. In this function, I have added one default parameter. This is default parameter. I'm not adding anything just after that, right? Comma, there are two variables here I'm passing, but I'm not passing the third variable. So what will happen, whatever the value epsilon is, it will just multiply with that 1, and it will check, is it less than that? If it is less than that, then this is equals to that. Okay. And if it is not, then it will not. Now the entire way of the epsilon is actually favoring us. Logically, it was correct, and we have also proved that with the help of epsilon, this is correct. But when we added more value, like 1000 added in the beginning, so this became false. It's saying it's not equal. But my understanding should be equal, right? 1000 is not enough. Yeah, see, now it is equals to 2000. So this inaccuracy is actually we are putting more load. In JavaScript, you can only represent up to 17 digit of number. Okay. So for that, we have a safe integer. So this max safe is the maximum safe integer value. This min safe, if you run this one, you will get two numbers. One is 90071 something, and one other is negative of that, just negative. So let's say there's a problem statement. You have to convert a number to a binary. 2 should be converted to 1 0, right? 3 should be converted to 1 1. There will be one possibility at some point you will not able to convert. You cannot represent the whole binary number. So how you will deal with that situation? So that's why we will create a function. Let's decode this code. Whatever number you put in this function, it will first check, is it under this? Means if you give 2 number or 3 number, it will check, is it under this number or not? I believe 3 is under this 9000. It will pass. It will not say cannot process the binary representation. We will store that value in num, and with the num, we will try to divide by 2. So this is modulus. If you do modulus, you will get the remainder of the value. So whatever reminder you are getting, I am changing to toString. toString will help us to convert to string value. Your number is 3, and 3 divided by 2 will give you 1 will be the remainder. Both will have 1 1 in the port. So I'm also writing a loop where so see here there are 3 condition in loop. One, first condition says the initial part. I have not give any initial. It will go on. It will just start because I have already initiated, so I don't need to go do it. Num, it will check the condition until num is greater than 1. Okay, and I have not added any updation, means there is no incremental value. So it will depend upon the condition whatever you have written. We can do it with the while also. So let's say you have 3 3 divided by 2 will get the reminder will be 1 to fetch the integer part, not the pointer part. And binary will store in string value. So it will give me 1 and I have binary 1. So both will give me 1 1. To the next iteration, it will check is it equals to greater than 1. So it will be false because 1 is greater than 1 is false. So it will not go up further, and it will come back and it will return binary 1 1. Okay. See the return value. So first convert the binary 3 is converted to 1 1. Hope you understood this whole functionality. Same thing you can check with method called number dot is safe. Put whatever you have a number and check that. So see this function, what it does, integer within safe. So if I pass any value inside this, it will first check is it safe integer. Safe integer will check the both condition. If it is safe, then it will return. If it's not, then it will say precision may be lost. And this value is fails safe. That's why it has just written the value. What if I give a long value, let's say more number here, will it still give me the number? See, precision may be lost. So it is more than this fails safe integer. We'll see you in next session. Hit the subscribe button to stay in the loop.